Okay, let's do a quick video on efficiency. So in a previous video, I talked about AMA and IMA and how AMA and IMA are rarely, if ever, the same. That's because we usually have a loss due to friction. We have a loss due to something. Maybe our forces aren't acting in the same direction. So let's take a look at this example here. So I have a lever that has an effort force of 16 pounds right here. Oh, it doesn't want me to draw. Give me a second. There we go. I have an effort of 16 pounds. I have a resistance of 32 pounds. My distance of effort is 5.5 inches, and my distance of resistance up here is 2.25 inches. So it jumped ahead for me. I was going to write for you, but that's okay. The AMA, so if you remember, AMA is equal to FR divided by FE. We want to know what AMA is. If you remember what AMA stands for, it's actual mechanical advantage. And so AMA in this case is FR divided by FE. FR is 32, FE is 16. And so if I do that, 32 divided by 16, I get a ratio of 2 to 1. You write, generally you want to write your mechanical advantages as a ratio. Okay? All right, so let's talk about IMA. So what is the IMA of the lever above? Okay, I'll let them do that, but I'll write this time. So IMA is equal to dE over dr. So in this case, dE is 5.5 inches divided by 2.25 inches. And since those cancel, I get a ratio of 2.44 to 1. Okay, so my IMA is equal to that. They're not the same. What does that look like for us? So why do you think that might be? Again, that could be maybe in my fulcrum here. It's not. You could think of your fulcrum as any point you're rotating around, and it could be a bike wheel, it could be a steering wheel, it could be a hose spigot, it could be, I'm thinking of, those all technically are going to be considered wheel and axles when we talk about them later, but it could be anything like that, and it just might have extra friction. That might be why you're losing some of your expected mechanical advantage based on your distances. Remember, IMA is what would you expect to get, AMA is what you're actually getting. So since it's different, we talk about efficiency. So efficiency is equal to AMA. What did you actually get divided by what did you expect? AMA divided by IMA. So if I do that, I get 2 divided by 2.44, which gives me 0.82. And when I do that, efficiency, typically you'll write it as a percentage. So if you remember to do a percentage, I would just take that times 100. And so I get efficiency is 82%. And that's probably in reality a pretty good efficiency. If you're dealing with 90+% efficiency, you've got a pretty solid simple machine or a complex machine really working. So you're going to lose a lot of different things due to friction, and then that translates to heat and other motion and things like that. So your efficiency, if you're sitting in that percentage, you're actually doing pretty good for yourself. So that's just a quick discussion on efficiency. It comes up in some of your practice problems, and so I just wanted to touch on that real quick. Good luck.